In a previous video, link in the description, we went over how to find the derivative of a log function with any base. The derivative of log base a of x is 1 over x times ln a. If the input of the logarithm is a function of x, say u, then we use the chain rule, and the derivative of log base a of u is 1 over that input u times ln a times the derivative, u prime. Of course, when using the chain rule, instead of putting the u prime out there, it's a little nicer to just throw it up in the numerator, and so that's how it looks with the chain rule. Now let's use these rules to find the derivatives of these 5 logarithm functions. Most of them use the chain rule, but the first one does not. Beginning with this first example, the derivative of log base 5 of x. We just apply this formula. It's going to be 1 over x times the natural log of 5. So it's 1 divided by the input times the natural log of the base. The base was 5, so natural log of 5. In the second example, the input is a function, x squared plus 1, and the base is 3. So in this case, we can start with 1 over the input, x squared plus 1, times the natural log of the base, so times the natural log of 3. But then, by the chain rule, we also have to multiply by the derivative of that input function. The function that's being put in the logarithm is x squared plus 1, so let's multiply by its derivative, which is just 2x. And if you prefer, we could just bring that 2x into the numerator of this fraction, and there is our derivative. The derivative of the natural log of x squared plus 1 is just like the previous example, except instead of ln 3, we would have ln of e, because that's the base of the natural logarithm. And of course, ln e just cancels out. So it would look like this, but the natural log of e is just 1, so we could just get rid of that, and this would be our final answer. When we're taking the derivative of a natural log of a function, the derivative is just 1 over that inside function, and then multiplied by the inside function's derivative. The ln of the base is just 1 because ln e is 1. In this next example, we have the derivative of log base 10 of 2 plus sine x. Again, we'll be using the chain rule, but we can start with 1 over the input times the natural log of the base. So there we have that, 1 over the input times the natural log of the base, but instead of having 1 in the numerator, we should just put the derivative of the inside function. The inside function is 2 plus sine x, the derivative of 2 is 0, the derivative of sine x is cosine x, and so that would be our final answer. Finally, the derivative of the square root of log base 2 of x. This is a little different from the other examples because this is a composite function, but the outside function isn't the logarithm. In this case, the logarithm is the inside function, and it's inside the square root. To take this derivative, it may help to rewrite that outside square root as a power of 1/2. Keep in mind we can't apply log rules here to bring the 1/2 out as a factor. That would only apply if the 1/2 was the power of the input, the power of x. In this case, it's the whole log function being raised to that power of 1/2, so that log rule does not apply. All right, to take the derivative of this, we need to start with the derivative of the outside function, which in this case is a power of 1/2. So we're going to use the power rule. Bring the 1/2 out front as a factor, and then reduce the power by 1. So that looks like this. 1/2 minus 1 is -1/2, so there we go. Notice we did not change the inside function. We're using the chain rule here, so the last step is to multiply by the derivative of that inside function. Of course, the derivative of log base 2 of x is just 1 over x multiplied by the natural log of the base, which is 2. And that's our derivative, which we could rewrite some if you like. 2 is in the denominator, and x ln 2 is in the denominator. And really, we could put log base 2 of x in the denominator as well, because it has a negative power. Its power is also 1/2, so we could also put it back in a square root if that's how you prefer to express your final answer. And it could look like that. 1 over 2 ln 2 x, and then root log base 2 of x. So that's how to take derivatives of log functions. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.